Welcome to Circuit Valley. I'm Gaurav. In front of you can see 4 different products from Ikea. This one is also spectrum adjustable from warm white, and this is also spectrum adjustable. It is only dimmable, not spectrum adjustable, and these two are only dimmable. They are dimmable, spectrum adjustable. They are all controllable from Ikea Hub. So why I have these products, all of them in the front of you, is today I'm going to tear them apart and show you what's inside. I'm actually planning a project where I have a custom LED strip on my workbench, and I want to integrate that LED strip into IKEA products, and IKEA LED driver does not really directly fulfill my requirements there. So maybe I'll modify one of these lamps to put into my custom system, and we'll see if I can use this existing circuitry to dim my custom 12 volt LED strip, which is not fitting with any of IKEA's current products. So first of all, we'll take them apart one by one, and I'll show you what makes them ting, what kind of LEDs they have, what kind of driver they have, what kind of circuitry they have. This is a very niche of a requirement, not necessarily everybody needs it, but still I'll try to modify them and integrate into my own system. Primarily this video you will get a tear down out of them. So we'll get started maybe with this big lamp, and I'll show you what comes there. It of course comes with a remote control. This remote control, of course, you can choose spectrum from these 2 buttons. This makes it turn on and turn off, while these can also adjust the brightness. Holding it on to increase the brightness, hold it down to decrease the brightness. It comes with these 3M tape and double-sided tape as well. And let's see, I'll take this lamp apart and we'll see how it goes from there. I'll be of course using my Victorinox. Most likely this dome comes apart. Okay, so it did come apart fairly easily, and you can see in front of you there are different kind of LEDs, and there's some kind of glue or thermal compound, and dome does not necessarily have anything, it's just a thing. So let's zoom in. I'll show you close by. I'll show you close up what is that. This is how it looks. I can see at least 4 different types of LEDs. These yellow phosphorus ones, I believe these are normal cool white LEDs. Red ones, they are primarily maybe warm white mixing with the cool white or something like that. And there is another type of 3 LEDs and another type of 3 LEDs. I do not know what their colors are, but maybe we can make a guess that R stands for red, blue stands for blue, and green maybe stands for, of course, green. So these 3 LEDs, 1, 2, 3 green, these another 3 are blue, and these 5 or 6 LEDs are red, and these are bright white LEDs. It appears to be that PCB connects to the underside with this connector. It has 8 pins. There is some circuitry there. Maybe I'll look at the part number of this particular IC, and I'll show you in a second. First, let me read the part number under a lens. So I have looked around. Maybe you can read it on your large screen. This IC is BP1638. It's some Chinese brand of RGB LED driver. So at least these center point RGB LEDs, they are driven by this IC. It expects 3 PWM inputs and drive these RGB channels. Nothing special. And these white LEDs, I believe you can see the traces that appears to be directly being driven from other circuitry and not being driven from this IC. We'll take it further apart and we will see what's down there, what is what is behind the driver. I have removed the silicon from the round and just putting my knife under it. It came out after a little bit of effort. So this is how the LED PCB looks. On the back, of course, there is nothing, and connector mechanism is quite easy. We'll see Zigbee Bluetooth module down there, and rest of the electronic circuitry is of course there. So we'll take it apart further. We'll see how can we take it apart. I don't know how to do it. Maybe we have to break something. Does it also have connectors? At least this is how it looks right now. So I've got my Victorinox again. Try to take it apart from this side. Okay, so this pin came out. Of course it was solder or something like that, and you can see on the bottom side, and now it should be relatively easier to take it apart. I think still not, because if you see down there, there's a red wire which is maybe attached to this post here. See if I can just pull it. Yeah, I can just pull it. This is how it came out relatively easily. So it's primarily power supply and the Zigbee module. We'll see what kind of power supply it is and how it's getting PWM and everything else through. This IC appears to be having only how many? 8 pins coming onto the PCB at least, and maybe 3 of them at least, or maybe some kind of other communication. 3 or 4 pins are at least needed for driving different LEDs, and 2 pins are of course needed for the power. So it has all the bare minimum coming out of it, it appears to be. I can also, of course, if I don't want to use AC power to experiment with this board, I can of course connect my bench power supply in maybe like 60-70 volt DC. Generally I have experience with these kind of systems. They generally turn on and they work reliably even with 30 or 40 volt DC. If you supply from here, 2 bench power supply channels can be put into series and supply power here. We can definitely try to experiment. First let me analyze, or let me take a look what's the circuitry. Maybe I can show you a little bit closer so that you can look at yourself. This is how the circuitry looks, and there is of course, I can see a few rectifiers, maybe a regulator or something like that. Let me take a look at the lens and we will see if we can make some guesses on the part numbers. So it appears to be that there are a few different power supplies, at least 2 different power supplies here, and 1 LED driver also. So this is your input rectification. You can see the power comes in and it goes one time to here to this rectifier, and another goes to this another rectifier. It appears to be that there are 2 separate rectifiers here. I'll show you why in a second. But this is a 12 volt regulator. It is a BP2522 from a Chinese company, and this appears to be the LED driver. The LED driver is part number is JW18287B. This appears to be the primary driver for the white LEDs. It is being powered from, I guess, from this 12 volt power supply, or it may be getting directly power from the AC supply as well. At least there's 1 rectifier and a few more rectifiers there. This guy is most likely getting power directly from the AC, not from the 12 volt supply. Maybe 12 volt supply for another driver, or for these LEDs, which are color LEDs there. And so 1 power supply, 12 volt, rectifier, another rectifier, LED driver, and if you see closely, there is 1 more power supply directly on the PCB. So this is the 3.3 or 2.5 volt regulator. It is part number is BP2525, and that's how the whole system works. This transformer, I believe, is the part of the LED driver circuitry for the white LEDs. So this guy generates PWM, has its own power and everything else, and it will of course then give you exact control. And you can see this on the 8-pin connector. Their markings D-, D+, NTC and GND. So they are definitely measuring temperature here somehow. And this, I believe, connects like this. So there's the NTC, D+, D-, NTC and GND, RGB LED, and very basic. So this circuitry is pretty much decoded. I'm not exactly sure why would you need a dedicated 12 volt regulator, as my guess was previously most likely for these LEDs or this chip. We will maybe try to power it on and we'll see what does it measure. So to give you overview of the ICs, this is the front IC BP1638, and it is just a simple MOSFET array of at least 3 MOSFETs to drive these LEDs through PWM. Nothing special, also Chinese part. And let's focus back to this IC. This is a LED driver for white LEDs, and this is this part number is JW18287. so this takes directly AC input from here, has its own rectifier, and it expects a PWM input as well, has some protection and some inductor as well. So this inductor which you saw on the back, this one definitely, this is this inductor. And these diodes, one of the diodes array is definitely belongs to this guy. As we saw that there are at least two different or three different rectification path. One for this LED driver, one for regulator, and another rectification path may exist for this particular regulator. So focus back, 12 volts regulator. It's a Chinese data sheet. BP2522X. Expect AC input directly provide you 12 volt supply. So another regulator, BP2525, is the regulator which is on the back side of this RF module or this Bluetooth module. If you see it, I don't know if you can see it or not, but it's right here. And this is the IC BP2525, directly supply you 3.3 or 5 volts. I believe it's going to be 3.3 volts. So now I have connected this supply to my bench power supply, and bench power supply is connected into series to supply him 64 volts on 2 channels, and we'll see if it started to work. With 64 volt, maybe at least 80 volts will definitely start to work. We may need the third channel, we'll find out. Okay, so I have it connected to 2 of the bench power supply. We will use our oscilloscope, we'll probe different things. So now I'll turn it on. So you can see it directly turns on into the last mode. I don't want to touch it because 60 volt DC is not that low of a voltage. Maybe just give you idea of that. It really changes the brightness. So this is how it looks. And I will use this command. So let's turn it off. And turn it off, turn it on, and we will try to switch into different spectrum. Did it change? Yes, it just changed into blue. It now turned into white. Let's take a look at the LED. This is the white spectrum, warm white. This is, I believe, bluish or red now, somewhat blue, with all the LEDs, green LED, red LED and blue LED all lit up. And now it is not changing. It has changed into red because you can see the blue LED is very dimly lit, and the green LED and red LED both are lit up. So now we are back again. So this is how you get, I believe, the cool white. No, it's still warm white, and now it's cool white. So you will see the blue LED and green LED and the warm white LEDs are on, red LEDs are off. So that's as easy as that. This is how it works. Now I'll use my oscilloscope and we'll try to probe from where the PWM comes in. We'll see if it works. So I located the pin, one pin going trace like this, from this to there, and we'll probe right here. This is the white LED. Maybe I'll show you how does it look. So this is the PWM. I do not have any ground reference because I don't know from where to take ground reference on this circuitry. Maybe I know actually. You can take ground reference from. Now this is the PWM signal, and if I increase the brightness, you see the on time increases, of course. I have a AC coupled. Let's switch this to DC coupling. Okay, now better. Now I'll decrease the brightness. So this is basically a PWM going into this LED driver circuitry and nothing special. I believe same thing happened with the other LED as well. Let's probe its input as well, and we have the P LED. So this is the P LED PWM, and it changes very tiny amount. It does not go all the way because it's supposed to produce a specific spectrum. So let's change the color, and now I am all warm white. Now I am blue. So now you see that blue LED has gone decent amount of almost 100% duty cycle on the blue color. So, and this is how it is. It's nothing special. 3 channels getting controlled by the. So now we'll go to the next lamp and we will see what's the difference between 2 circuitries, and if it is any difference. It has, this particular lamp happened to have 4 different channels of PWM, 3 for RGB and 1 for the, what do you call it, this pure white LED. The next product is this, again the same name, but it has only, I believe, only the spectrum of warm white to cool white, or maybe just 1 single channel, I don't know, we'll find out. Let's take it apart. Same process. The lamp is off, and it's only the brightness control. It does not have any spectrum control. So as it says here, only the brightness control. What's the part number of this particular thing? So this is the Ikea part number 6054196. This only has adjustable brightness. It does not have any adjustable spectrum or anything else. So let's take it apart, and you can already see it has only 2 contact pads and nothing else. So of course there's only 1 array of LEDs. So only 2 contact pads are enough. Screw in a bit. Now it's done. So only 2 contact pads poking out. Same thing we will do on the back side. One contact pad is gone. I'll just pull it and hope that another contact pad will automatically be dissolved. Yeah, very easy. So let's zoom in. This is how the circuitry looks. Very clean. Nothing special, and we see this, I believe it's going to be the same LED driver, same 3.3 volt power supply, and there is no power supply of course on the back side. So similar thing. Rectifier, LED power supply. This rectifier may belong to these people, or this rectifier belong to this guy, and 3.3 volt power supply, LED driver driven by PWM. Nothing special. If you want, we can power it too and see if it works. So I've connected to my bench power supply with 80 volts set, 30 volts on one channel, 30 volts on one channel, and 20 volts on one channel, and it of course lights up. This happens to be that only 6 pins are soldered, and of course one of the pins here is PWM. That's how this IC is driven. So this is done. We will go back to another lamp, and so that we can see that how the other lamp is made. I'll maybe integrate one of these circuitry into my projects, and that's how I'll do it. So this is another product, 705-18179. It appears to be that it has spectrum, not the RGB spectrum. At least few colors should be there. It's relatively smaller. I could not find anything else in this price category, that's why I ordered it. So you can see that to save space, they have this thing sticking out, or at least it has at least two different kinds of LED. So this may be the best candidate for my project because I need something that can do spectrum, warm white, cool white, and that's it. I don't have any RGB, any requirements. Okay, then, okay, I think it's out already. I just need to put my knife underneath and we are done. Okay, so this is done here. Maybe I can just pull it. Is there any contact? There are no contacts there. So there we have it. Very tiny circuitry. There's just one single driver, and I wonder how do they do 12 PWM on it, or one of them always stays on and another one just comes in and goes out. I'll pair my remote. I only have one remote actually. Pair my remote to this guy and we will try to power it and we will see if it works. And if it works, how does it work? So you see all the LEDs have lit up. Right now there's no remote paired on it. So we'll do pairing first and we'll see how does it work. So as you know that these bulbs, they do not have any pairing button or anything else. So to pair them, you're supposed to turn them on and hold this pairing button. So I'll hold it for 10 seconds. You see this gets into the pairing mode. I don't know if it is doing anything. Yeah, so the remote is paired. So you turn it on, turn it off, and turn it on, and I want to dim the brightness to maybe minimum so that you can see there are two different colors of LED. Maybe a little bit brighter, or maybe even further dim. Ah, that's too dim. Yeah, that's better. Now you can see this only warm. This is not visible on camera properly, but it's only warm. And this is warm and white both. So I got it a little bit figured out. This is the only one LED driver, and it drives both of these LED strings, and there's circuitry here which can bypass one of them. So when you turn it on, this is the PWM here on one number, and I can see 50% duty cycle. So this sets the duty cycle for both of them, and you cannot individually set their brightness. They are going to be either equally bright, equally warm, or alternatively they will be, one of them will be on, one of them will be off. So only one PWM channel controlling both of them, either equal brightness or one off or one on. One cannot be on 10% and another cannot be at 50%. That's not possible because there is only one PWM driver. There's a difference between both of them. So it's a little bit tricky circuitry. Of course, Ikea played all the tricks to save some money. So now we will move to this last one and we will see how this one works. This one is going to be a little bit tricky to open because it is primarily glass and I do not want myself to be shattered by the glass all the places. So let's maybe turn it on first. Don't worry, it's I'm supplying him low voltage DC. Seems like 3 watts on this. Of course it works. Let's find out a way to open it. So I think we'll just try to use the sharp edge of the knife and carefully try to pop the front of this. Oh shit, we broke the glass. It didn't hurt myself, it's okay. It's quite thick of a plastic actually. Now it's coming out. So only one color LED, only one color LED. So it of course does not have any spectrum. It's fixed color temperature. Only brightness is adjustable. We'll take it further apart, but how? Because it's glued in, and I do not see a way to hold it. It was easy. So very easy. One color LED of only 2 contact pads, and this one does not have connector. It has PCB and contact pads. Totally different thing. Every single time Ikea implements something different, it doesn't come out. Maybe I'll break them on the back side. Attached pretty snugly actually. Okay, so we got the PCB out and it was attached with pretty heavy pins. That's why it was not coming out easily. Same stuff, one rectifier, one regulator for electronics, one LED driver, and that's it. So that's it for this video. Once this project progresses, maybe I'll give you some updates. So we had these different LED drivers, and only this one has full RGB control, while this one has only one channel, and this had 2 channels but implemented in such a way that only one PWM channel exists. So this is the solution. I'll clean up, and that's it for this video. You can visit my website www.circuitvalley.com.